Okay, so we're going to talk about the intermediate value theorem. And the intermediate value theorem is kind of cool. You can read it in the book more, if you want to see their explanation. And the nice thing is we kind of work with integers usually for this type of idea, although they don't have to be, but a lot of times they'll give it to us that way. All right, so let's say we have a graph, and say there's a point at A, and then say this is it maps to f of A, and so there's a point right here, okay? So we see A and we see f of A. This point would be A, comma, f of A. Okay, not a 9. Okay, then let's say you have another point over here at B when x is B, but let's say that f of B is negative. Let's say it's down here. Okay, well, and then this point would be B, comma, f of B. It doesn't matter how many turning points there are between A and B, or what kind of polynomial you have. It could come up here and do whatever, but whatever's going to happen, it's going to cross somewhere between A and B. Like I said, it doesn't matter how many turning points you have. It doesn't matter what the degree is. If A has a positive value up here, evaluates to be positive, and B is evaluating to be negative down here, then somewhere between A and B, it had to cross the x-axis. That is the intermediate value theorem. Now, it works the other way as well. So let's say you have, do another one here. Say you have A as being negative, so down here, f of A, and at some point, and then you have B, and it's got a point up here that's positive, then no matter what the turning points are, or what the polynomial is looking like, at some point it has to cross between A and B. So what we're really saying with the intermediate value theorem is, if you have 2 points, and one has an output that's negative, and one has an output that's positive, then somewhere between it had to cross the x-axis, okay? That there would be a 0 between the 2 points, okay? So in this case, there is a 0, or an x-intercept, between A and B. And you can say the same thing over here on this graph, okay? Either graph. So that's what the intermediate value theorem says. If you evaluate at one number and you evaluate at another number, and one turns out positive and one turns out negative, then somewhere between those two numbers, A and B, you had to cross the x-axis. I hope that makes sense. You might be saying, well, that doesn't really tell me a lot, so how am I going to use this? Well, we'll see it in the next problem.